Good day. I will be your chemistry teacher for this session. Today, we shall be discussing the topic thermochemistry. Introduction. Energy is the capacity or ability to do work. Energy appears in different forms, some of which are kinetic, potential, chemical, heat, electrical, and light energy. The conversion of energy from one form to another occurs all the time in natural and man-made activities. Some examples of energy conversions are food. A form of chemical energy is converted to heat when digested. You will recall that nutritionists talk of caloric value of classes of foods. Fuel, petrol, diesel, also a form of chemical energy, is converted to heat when it burns and then to mechanical energy for motion. Our emphasis today is on heat energy released or absorbed during chemical process. The chemistry that deals with chemical reactions accompanied by heat energy is called thermochemistry. Thermo means heat. Objective: at the end of this lesson, students will be able to 1. Define enthalpy, entropy, free energy, and write equations that connect them. 2. Distinguish between exothermic and endothermic reaction. 3. State the formula to calculate enthalpy of a reaction. 4. Draw the energy profile diagram for exothermic and endothermic reaction. 5. Write a thermochemical equation. 6. State factors that affect enthalpy of a reaction. 7. Define different types of heat of reaction. 8. State Hess law and laws of thermodynamics. Energy changes in chemical process. Heat content and heat of reaction. The energy a chemical substance possesses as a result of its structure and physical state is called its heat content or enthalpy. The change in energy that accompanies a chemical reaction is called the heat of reaction. In energy calculation, enthalpy and enthalpy change are given by the symbols capital letter H and delta capital letter H, respectively. The absolute value of the heat content cannot be measured for chemical substance, but the heat or enthalpy change can be measured or calculated. For a chemical reaction, delta H of reaction equals to HP minus HR, where HP and HR are the enthalpies of the product and reactant respectively. For reactions involving many reactants and products, the equation becomes delta H of reaction equals to sigma HP minus sigma HR, where your sigma means summation. Endothermic and exothermic reaction. A chemical reaction is either accompanied by evolution or absorption of heat. Evidence of heat evolution is an increase in temperature. The reaction vessel is warm or hot to the hand. This is the exothermic reaction. For the endothermic reaction, the temperature decreases and the reaction vessel feels cold to the hand because of heat absorption from the surroundings. Recall that heat of reaction equals to HP minus HR, and delta HR of reaction is summation HP minus HR minus summation HR. When the total heat content of the product is less than that of the reactant, the enthalpy change is less than 0. That is, delta H is negative. The difference in the heat content is given off to the surrounding. An exothermic reaction is a reaction in which heat is given off and delta H is negative. For the endothermic reaction, delta H is positive, that is, HP is greater than HR, and heat is absorbed from the surroundings. An endothermic reaction is a reaction in which heat is absorbed and delta H is positive. Energy level diagram. The energy change in a chemical or physical process can be represented on a plot of potential energy change against the time of reaction. The energy change marked EA on the diagram is known as activation energy. The activation energy is the minimum energy needed by the reactant before the reaction can occur. All reactions, whether exothermic or endothermic, requires activation energy. When reaction takes place between molecule or atom, it usually involves breaking of old bonds between atoms or molecule and the formation of new ones. These processes are not consecutive but occur simultaneously, at which point an activated complex is said to be formed. The activated complex is a temporary phase of the reactant whose duration is extremely brief. I'll see you again. Welcome back. Now we go on to thermochemical equations. The heat content of reactants and product of a reaction depends not only on their chemical structure but also on their physical state. The following factors can affect the enthalpy of a reaction. 1. Amount of reactants and product. Here, the heat of a reaction is proportional to the amount of reactants used up or products formed. The enthalpy change is normally given per mole of a reactant or a product. 2. A change in temperature or pressure for gases. It is therefore very necessary to state the temperature and pressure of measurement if different from the standard state. 3. The physical state of the reactants and product. It is important to state the physical state of the reactant and product. 4. The concentration of salt or ions in solution. The concentration of the ions involved must be stated if different from the standard of 1 mole per dmq. The chemical reaction equation, which gives the physical states of the reactants and product as well as the heat change that accompanies the reaction, is called a thermochemical equation for the reaction. For example, when carbon in solid state reacts with oxygen in gaseous state to give us carbon 4 oxide in gaseous state, the enthalpy change for that reaction is given as delta H is equals to minus 393 kilojoules per mole. Types of heat of reaction. Reactions are of many types. The heat change will be defined and named according for formation, combustion, neutralization, and solution. The standard heat is defined in each case. Number 1, standard heat of formation, delta HF. The standard enthalpy of formation of a compound is the heat evolved or absorbed when 1 mole of the compound is formed from its elements in their normal state under standard condition. Heat of formation is useful in calculation of heat of reaction, that is, delta H reaction equals to summation HF of product minus summation HF of reactants. Number 2, standard heat of combustion. This is the heat evolved when 1 mole of the compound is completely burnt in oxygen under standard conditions. Note here that combustion reactions are exothermic reactions. Combustion reactions are very important since they form the main source of energy for industrial and domestic purposes. Heat of combustion is useful in the calculation of heat of formation and reaction. That is, we now have HF equals to summation Hc reactant minus summation Hc of the product. Number 3, standard heat of neutralization, delta Hn. This is the amount of heat evolved when 1 mole of hydrogen ion from an acid react with 1 mole of hydroxide ion from an alkali to form a mole of water under standard conditions. Number 4, standard heat of solution. The standard heat of solution is the heat evolved or absorbed when 1 mole of a substance is dissolved in so much water that dilution results in no change in heat. Number 5, enthalpy of change of state. Now, there are 3 main physical transformations that can occur for a given substance. These are solid to liquid, which is melting or fusion, liquid to gas, vaporization, solid to gas, sublimation. The molar heat of fusion is the heat energy required to convert 1 mole of the solid to the liquid at melting point, while molar heat of vaporization is the heat energy required to convert 1 mole of the liquid to the vapor at boiling point, while the molar heat of sublimation is the heat energy required to convert 1 mole of the solid to gas at the same temperature. Therefore, delta H of sublimation is equals to delta H of fusion plus delta H of vaporization. Thank you. I'll see you again. Welcome back. Now we go on to determination of heat of reaction. Here, the measurement of absolute enthalpies of compound is not possible, but enthalpy changes can be measured in the laboratory. The measurement of heat changes that accompany reactions is called calorimetry, and calorimetry experiments are done in specially insulated containers called calorimeters. The word calorimetry and calorimeter come from the word calorie. A calorie is the amount of heat energy required to raise the temperature of 1 gram of water through 1 degree centigrade. The SI unit of heat is joules. 1 calorie is equals to 4.2 joules. Calorimeter are of many types. The bomb calorimeter is fairly sensitive calorimeter used in the measurement of heat of combustion. In all calorimetry experiments, the major measurement is the temperature change that accompanies the reaction of a known amount of reactants in a calorimeter of known heat capacity. Now, heat capacity is the heat energy required to raise the temperature through 1 degree Celsius. The heat enthalpy then is given as delta H equals to M multiplied by C multiplied by delta T, where M equals the mass of water, C equals the specific heat capacity, and delta T is change in temperature. Many calorimetry experiments are done at temperature and pressures different from the standard states. The heat of many reactions cannot be measured directly because of experimental difficulties, such as the nature of the reactant, the rate of reaction, and the magnitude of the heat. Where the heat cannot be measured, they can be calculated from the heat of formation or the heat of combustion of the reactant and products. As heat of reaction is in terms of heat of formation, it's now be summation heat of formation of product minus summation heat of formation of reactant, or heat of reaction is given as summation of heat of combustion of reactants minus heat of formation, heat of combustion of the product. Hess law and the Barnaba cycle. The enthalpy change of a chemical reaction can be found experimentally. It can also be found theoretically from known values of enthalpy change of related reaction. That is, it is possible to determine heat of reaction that are difficult or impossible to carry out experimentally. This is done by using the Hess law of constant heat summation. The law states that the total enthalpy change of a chemical reaction is constant regardless of the routes by which the chemical change occurs, provided that the condition at the start of a reaction are the same as the final condition. That is, the heat involved in a chemical reaction is the same irrespective of the number of stages involved in the reaction. Hess law can also be represented in form of Born-Haber cycle, which is a combination of an energy cycle and energy level diagram, such as if you have potassium reacting with oxygen to form potassium oxide. And so you have here as heat of formation of potassium oxide to be heat of sublimation plus heat of dissociation plus ionization energy plus electron affinity, bond energy. Energy changes in chemical reaction are due to the breaking and forming of bonds. This is the energy that is absorbed when a particular bond is broken or evolved when it is formed. Thus, it is the amount of energy associated with a particular bond in an element or a compound. Generally, a positive change in enthalpy is required to break a bond, while a negative change in enthalpy is accompanied by the formation of a bond. In other words, breaking a bond in reactant is an endothermic process, while the formation of bond in product is an exothermic process. Chemical thermodynamics now. Thermodynamics is a study of relationship between heat and other forms of energy. Heat is represented by the symbol Q, small letter Q. All other forms of energy is referred to commonly as work, represented by W. The relationship between heat and work is expressed in the laws of thermodynamics. The first law of thermodynamics states that energy may be converted from one form to another, but it can not be created or not destroyed. This is also law of conservation of energy. Mathematically, change in internal energy equals to heat absorbed by the system plus the work done by the system. When the system is gaseous, the work done is given by P multiplied by change in V, where P equals to pressure and change in V equals change in volume. Second law of thermodynamics, most exothermic processes occur spontaneously. Other factors which exert an important influence on determining whether a process can occur spontaneously are 1. Entropy and free energy. Then entropy. Entropy S is a property of substance measured in joules per Kelvin per mole. It is a measure of the degree of disorderliness or randomness of a substance. A crystalline with highly ordered structure usually has a low entropy, whereas a liquid has a higher entropy value due to a less ordered arrangement of molecules. In a gas, molecules are moving continuously and randomly. There is little order and the entropy is relatively large. Generally, for a given substance, as temperature increases, the degree of disorderliness or entropy increases. There is a large jump in entropy when solid melts and the liquid vaporizes. The influence of entropy on a process is given by the second law of thermodynamics, which states that a spontaneous process occurs only if there is an increase in the entropy of a system and its surrounding. Thus, entropy S is given as delta H over T, where delta S is your entropy, delta H equals to enthalpy of the system, T equals to temperature of the system. Also, you can also calculate entropy as summation of entropy of the product minus summation of the entropy at the reactant side. Then free energy. Another factor that determines whether a process will occur spontaneously or not is the change in free energy of a chemical system. The free energy of a chemical system, G, is the energy which is available for doing work. This is the driving force that brings about a chemical change. The value of G can be given as delta G equals to delta H minus T delta S, where the delta G equals to free energy, delta S equals to entropy, change in entropy, T equals to temperature. Now, for a chemical reaction to occur spontaneously, delta G must be negative. If delta G is positive, the reaction is not spontaneous. And if delta G equals to 0, the system is in a state of equilibrium. Thank you. I'll see you next time.